Hi everyone! I hope you're enjoying your virtual day. I'm going to start by reviewing example number 8 from last week. So on number 8, we are determining if x plus 2 is a factor of that polynomial x cubed plus 5x squared plus 8x plus 4. So remember we said to determine if it is a factor or not, we need to divide and see if our remainder equals 0. So because our divisor x plus 2 is in that linear format that synthetic division is possible, I'm just going to go ahead and use that since it's a little bit faster than long division. So remember to figure out the number that goes in the little box. We take our divisor and set it equal to 0, and we get -2 for our x. So this is the number that's going to go in the little box there. Also remember to set up your synthetic division. Across the top there, we're going to take the coefficients from our dividend, which are 1, 5, 8, and 4. Also remember if there were any missing terms after the x cubed, then we would need to put a 0 in there. So if that 5x squared was missing, we would still need to put a 0 there where that 5 is. So luckily we weren't missing any terms on this one, so we didn't need any zeros. So to do your synthetic division, remember drop down the first coefficient under the line, then you multiply the numbers under the line by that number in the box, that -2, and you write it underneath the next coefficient, and then you add straight down. So 5 plus -2 is 3. Once it's under the line, we multiply it by the number in the box, -2, so we get -6, and we write it underneath the next coefficient. Then we add straight down. So 8 plus -6 is 2. And again, we multiply by the -2 in the box to get -4. And when we add straight down this time, we get 0. So remember that last number is your remainder. And because the remainder is 0, then now we know that yes, x plus 2 is a factor of this polynomial that was given. So up in the directions, it says we can rewrite this polynomial as a product, which is two things being multiplied together. So this polynomial right here, x cubed plus 5x squared plus 8x plus 4, can be rewritten. It equals a product, and that product is going to be the divisor, x plus 2, times the quotient when we divide by x plus 2. So our quotient, remember, is down here. These are the coefficients of our quotient. So working backwards, we have the constant, we have the x or linear term, and we have the x squared or the quadratic term. So the quotient when we divide here is x squared plus 3x plus 2. All right, so even though none of our factoring methods that we know of, like when we have 4 terms here, if we had tried to factor that original polynomial using grouping, it wouldn't work because we wouldn't get the same thing in the parentheses that we needed. But by using this synthetic division, we can find a number that gives us a remainder of 0, and then we can still end up factoring our original polynomial using this synthetic division. So in our next example, what we're going to learn today is we're going to look at a polynomial that doesn't use one of our factoring methods we learned last week, and we're going to make a list of possibilities for numbers in the box here. So not all the numbers we list are going to work, but we're going to make a list that we can get started to work with in order to get this remainder of 0. Okay, so when I say we need a factor or a possibility that works, that's what I mean. It needs to divide evenly and give us a remainder of 0. So look at example 12 in your packet. So on example 12, the rational root theorem is listed right above it. So all of the possible rational roots, all of the possibilities of solutions are going to have this format here. P over Q. All right, and so if you look right above that right there, it says that P are the factors of the constant, and remember the constant is that term that doesn't have an x at all. The Q's are the factors of the leading coefficient. And the leading coefficient is that number in the very front if that polynomial is written in standard form. So our p's are going to be the factors of the constant 6. And then the q's on the bottom are going to be the factors of our leading coefficient, which is 1. So on the top up there, oh, and it's also plus or minus. Notice that in the thing there, directions. So the factors of 6 are 1 and 6 and 2 and 3, but it could also be -1, -6, -2, and -3. So we're just making a list right here, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So that's just a list there. And then on the bottom, we need to list out all the factors of our leading coefficient. On this one, it's really easy because it's just positive and -1, because 1 and -1 are the only things we can multiply to get 1. So because we only have a 1 on the bottom, if we take every single number on top and we divide it by 1 on the bottom, we're just going to get those numbers on top. So it makes it a little bit easier when our leading coefficient is 1. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 are the possibilities for solutions, okay? And those are not all solutions to this equation, but this is a good starting point. So step number 1 is to list out all of the possible factors. These are our possibilities. Step number 2 is to test each of those possibilities until we get a remainder of 0. So we need to set up our synthetic division, and we just need to try those numbers. So remember, for synthetic division, our leading coefficients of our original polynomial need to go across the top. So we have 1, -2, -5, and 6. So if we're going to try out one of these numbers, let's just try positive 1 and see what happens. We're going to just try all 8 of those numbers on our list from step 1 and see what happens. So I'm just going to try positive 1 first. You can try any of those 4 numbers first. It doesn't matter which. So drop the first coefficient under the line, then you multiply by the number in the box, and then we add straight down. So that's -1. So now we need to multiply again. So that's -1, add straight down to -6, multiply by the number in the box, and add straight down. And luckily, the first one I picked ended up working. Sometimes the first number that you choose from your list doesn't give a remainder of 0, and then you know that that's not a solution, and you have to pick a different number from the list to try again. So once you do find a possibility that works, you can rewrite the original polynomial in factored form like we did on the example. I think that was number 8 that we just did. So the original polynomial can be rewritten as the divisor times the quotient, okay? So remember, if we had a positive 1 here, then our divisor is opposite that. Remember, it's going to be x minus 1. So when we set x minus 1 equal to 0, we get that positive 1 as the solution. So this function, f of x, remember, we're finding the roots, so that's where your y or f of x is 0. So instead of writing out the polynomial, we'll write it as the divisor, x minus 1, times the quotient. And remember, the numbers at the bottom of your synthetic division, those are your coefficients of your quotient. So we have a positive 1x squared, we have a minus 1x, and then we have a minus 6. And then from here, we can see if that quadratic factors using the methods we learned last year. So we need to think, are there 2 things that multiply to -6 and add to -1? And we do have numbers that do that. So the 2 numbers that multiply and add correctly are going to be -3 and +2, because -3 times 2 gives you that -6, and -3 plus 2 gives you that -1. And then remember, once your polynomial is factored completely, you can separate each factor and set each one equal to 0 and solve those independently to get your solutions. So on the first one, obviously, we get our positive 1. And remember, we already knew a solution was positive 1 because this is the same positive 1 that we had up here when we did our synthetic division. And then when we set the other factors equal to 0, we get positive 3. And on the last one, we have to subtract 2 to get x alone, so we get negative 2. So those are our solutions to example number 12. Remember, whatever the degree of your polynomial is, that's how many complex zeros you should have, whether they're real or imaginary, when you're done. So we have our 3 real solutions on this one. If we look at example number 13 next, the first thing that I notice on this polynomial is that all of the terms in my equation all have an x. So we can kind of combine our factoring with what we just did with the rational root theorem and the synthetic division. So the first thing that I'm going to do is factor out an x out of this. So we get negative 2x cubed, and then minus 11x squared minus 12x plus 9. So you can definitely factor out your greatest common factor first, and then we can do what we just did with our p's and q's to finish factoring this one using that synthetic division. So the x on the outside, we're just going to completely ignore it for the moment, and we're going to do some synthetic division, some scratch words, and some p's and q's, and list those out. So remember our p's and our q's. P's are the factors of the constant. So we're going to list out the factors of 9. And on the bottom, we're going to list out the factors of the leading coefficient. And our leading coefficient is negative 2 here. So factors of 9, we have 1 and 3 and 9. And on the bottom, factors of 2 are 1 and 2. So this one, when you list your p's and q's, is a little bit trickier than the last example because you actually have 2 numbers on the bottom here. So you have to divide every single factor on top by every single factor on the bottom. All right. So I always divide all of my factors on top by the 1 first. So 1 divided by 1 is 1. And then on the top, 3 divided by the 1 on the bottom is 3. And then 9 divided by 1 is going to be 9. But now we also have to divide all 3 of those factors on the top by the 2 on the bottom as well. So 1 divided by 2 is going to be 1/2. So plus or minus 1/2 is also in this list. And then if I do 3 divided by 2, then that's 3 over 2. So that should be in the list. And then 9 divided by 2 should also be in the list. So these are all the possible rational roots, or the possible rational solutions. So again, in order to determine which one actually works, or it has to divide evenly. So remember, when you do your synthetic division, you should have a remainder of 0 in order for that to work. All right, so I'm going to set up my synthetic division. So we have negative 2, negative 11, negative 12, and 9. And then we need to pick a number from our list of possibilities to put in our box to see if we get a remainder of 0 or not. So positive 1 worked for me last time, so I'm just going to try positive 1 again. So let's just see what happens. So bring down your first coefficient, and then once it's under the line, you multiply by the number in the box, and then you bring straight down. So that'd be negative 13 times 1 would be negative 13. So if I add straight down, that's going to be negative 25. And as you can see here, when I add that to 9, I am not going to get a remainder of 0. That's not going to work. So I need to undo. I need to try another number from my list. So let's try negative 1 and see what happens. All right, so I'll bring down your first coefficient, multiply by the number in the box, Now we need to bring add straight down, so that would be -9. So if I multiply, that will be +9, and then we do not get a remainder of 0 again. So we need to try another number from the list. So I'm going to try +3. Drop your first coefficient underneath and multiply. Then we need to add straight down. If I do -17 times 3, that's going to be -51. And you can see when I add that straight down, it's going to be a negative number times 3, and it's not going to give me a -9. Because in order to add to 9 and get a remainder of 0, we need -9 in that last space there. So +3 isn't going to do it for us. So let's try -3. As you notice, I'm just going down this list. 1 and -1 didn't work. Then I tried +3. Now I'm going to try -3 and see what happens. Hopefully we'll get a hit here. All right, drop down -2. Now we're going to multiply, so that's +6. So that's going to give us -5. -5 times -3 is a +15. Then we add straight down and we get 3. Oh, look, this one does work. 3 times -3 is -9. So when I add, the remainder is 0. So thank goodness we got -3 as a solution. So now what we have to do is we have to write this original thing in factored form in our next step down here. So the x that's hanging out in the front, keep that x there. And then the -3, that is our solution in the polynomial. Remember, that's going to be x plus 3. Remember, the actual solution and the factor, those are different or opposite signs there. And then remember, we have to multiply that divisor times the quotient. And the quotient are the coefficients -2, -5, and 3 that we got from the synthetic division. So this is going to be a -2x squared minus 5x plus 3. And this equation is still equal to 0. We're still trying to solve for x. Whenever I factor quadratics, I like having my leading coefficient, I like having it be positive. So I'm just going to factor a -1 out of this quadratic, and I'm just going to put it in the front there. So if I factor that -1 out of this quadratic, it'll be a +2x squared, a +5x, and a -3. So now from here, I'm going to factor that quadratic there. So since there's a number in front of x squared, I have to multiply 2 times -3. So I need two numbers that multiply to -6, and they need to add to the middle term +5. So it looks like +6 and -1 are the numbers that are going to do that for us. So all of this is just hanging out here. And then our quadratic, we're going to turn it into 4 terms and do grouping with it. So remember, leave your first term the same. Replace the middle term with the two factors that we just found. So that was 6x and -1x. And then leave that fourth term, or that last term the same. That third term is going to become our fourth term there. And now we can factor by grouping. And I'm just going to see if I can get my page extender here to move down a little. All right, so all of this stuff is still here. All right, so let's factor by grouping. So if we group the first two terms, our GCF there is going to be 2x. So when I divide that out, you get x plus 3. Then the middle symbol goes next, so it's going to be a minus this time. And then the GCF of 1x minus 3 is just going to be 1. And if you notice, it's a -1 that's there, not just a 1 that we're factoring out. So -x divided by -1 is +x, and then -3 divided by -1 is a +3. So in our next step, we have our -x and our x plus 3 still hanging out there. And then we're going to factor out the x plus 3 here as a GCF. We're finishing grouping here. So when we divide that out, we're left with the 2x and the minus 1. And we are finally done factoring this one. So now we can set each factor equal to 0. So negative x equals 0. X plus 3 equals 0. We get another x plus 3 equals 0. And we get a 2x minus 1 equals 0. So on the first one, divide both sides by negative 1. X just equals 0. On the second and third one, you get x equals negative 3 on both of these. So what we're going to do is we're going to say that x equals negative 3, and this is called a multiplicity. So it's a multiplicity of 2. So a multiplicity just means you're getting the same answer more than once. So this is a multiplicity of 2, meaning we got the same number as a solution twice. It's possible to have a multiplicity of 3 or a multiplicity of 4 if you get the same number more than once. So that's just a vocabulary word that you may or may not have learned. So it's a multiplicity of 2 here. For the solution, x equals negative 3. And then on my last one, I'll add 1 to both sides, and then I'll divide by 2. So x also equals 1/2. So we got 4 different answers here. We got 0, we got negative 3 twice, so 0, negative 3, and then 1/2. So those are our solutions to this one. There's one last example I want to do with you, and this is just showing you how to use the graphing calculator to get the solutions instead of doing it by hand. So when a calculator is allowed, it will actually find these solutions for you, which is great. So grab your graphing calculator. So the first thing that I want to do is I want to type my function into my calculator. So I'm going to hit the y equals button, which is at the top left. So once you hit y equals, type in your equation. So we have 2x to the 5th. Remember, x is this button right here next to the green alpha button. And then your exponent button is the little arrow above division. And then you have to arrow to the right to get out of the exponent. Then we have plus 3x to the 4th power, arrow out of the exponent. Then we have minus 12x, and we have plus 4. All right, so from here, if you want to look at the graph of this, you can just hit the graph button. Now my window is really weird and kind of funky because I was doing a different problem before this. So just to recenter your graph at 0, 0, you can hit zoom, and then any of these right in here all kind of center at 0, 0 for you, like zoom 4, 5, or 6, decimal, square, and standard. I usually just use zoom 6, because that takes my window from negative 10 to positive 10 in both the x and the y directions. So our zeros, remember, that's when we said the y value equals 0. Remember, our equation was equal to 0 on all of these. So if y equals 0, those are x-intercepts. So your zeros or your roots are on your x-axis. So we're looking for x-intercepts. Anytime you want the calculator to calculate something from a graph for you, you're going to hit the blue second button, and then you're going to hit the trace button that says calc in blue right above it. So if you hit second trace, this is the calculate menu for graphs. So anytime you're on a graph and you want the calculator to calculate something from the graph, you have to hit second trace, and it takes you to this here. So what we're trying to do is find zeros or roots or solutions. So you can see number 2 right here says 0. So you can just hit the number 2, or you can arrow down to where 2 is highlighted and hit enter. I just hit the number 2 because I think it's faster. Now from here, if you notice at the bottom of the screen, it says left bound. So this means that this little flashing cursor needs to be moved to the left of the 0 that you are trying to calculate. So I'm going to try to find this x-intercept right here, this very first one. And eyeballing it, it looks like it's negative 2 point something, okay? But remember, on the AP exam, you need at least 3 correct numbers after the decimal. So we can't just eyeball it, we have to calculate it exactly. So if I'm going to find this one right here, I'm going to use my arrow to the left here to move that cursor to where it's past that negative 2 point something that I just said. So you can see my cursor is way up here. So that's technically to the right of it. So I need to go to the left a little more. So down here, this would be considered left of that x-intercept. So I'm going to hit enter because I'm to the left of it. Now you can see the screen is saying, where is the right bound? So now I need to move to the right with my cursor, and I need to be on the opposite side of the x-axis, to the right of the x-intercept. So here I'm on the opposite side of the x-axis, I'm to the right of the 0. So now I can hit enter. And then for guess, see how it says guess right there? You can either get your cursor pretty close to it and then hit enter again, or you can just really just hit enter again. And then there's your 0. So you can see that we have negative 2.1737. So negative 2.1737. So instead of just writing 3 numbers, you may want to write 4 just to guarantee that the first 3 numbers after the decimal there are correct. Now, if you notice, y doesn't exactly equal 0 here, but this is scientific notation. This is 6 times 10 to the negative 12th power. So this is 0.000000000, 11 zeros, and then a 6, okay? So it's very teeny, tiny, and it's essentially just 0. So you don't have to worry about that there. All right, if you notice, this function is crossing the x-axis 2 more places. So we have to calculate both of those as well. So I'm going to find this next one kind of closest to the y-axis next. So remember, if you want to calculate anything from the graph, you hit the second button and then the trace button. And we're finding zeros, so we're going to select number 2. Now, again, we need to be to the left of our x-intercept. So I'm actually going to arrow to the right to get closer to it. My cursor's off the screen, but if I keep going, I'll see it again. There it is. So my 0 is right about here. So I'm going to go to the left of it a little bit. So right about here is going to be to the left of my x-axis. So I'm going to hit enter. Now it says go to the right of your x-intercept. So I'm going to click the right arrow until I'm on the opposite side of the x-axis. So I know I'm going to be below it this time since I was above it the first time. So now I'm going to hit enter. And then for guess, remember, you can just hit enter a 3rd time, or you can get close and then hit enter. And then ta-da, there's your next x-intercept, or 0 of your function there. So we have 0.3372. 0.337. This is the minimum number of numbers that you need to write for that solution. Remember, you have to have at least 3 numbers correct after the decimal. All right, so let's find the third and final 0 there. So anytime you're calculating something from the graph, you hit second trace. We're finding zeros, so we're selecting number 2. Now our cursor needs to be closer to the x-axis we're looking for, but we need to be to the left of it. So to the left of it would be down here this time. So I'm going to hit enter. Now I need to hit the right arrow and go to the right. And it should be on the opposite side of the x-axis. So I'm going to hit enter here. And then you can just hit enter a 3rd time. And ta-da, there's your final 0. So we have 1.171. 1.171, I believe is what I just said. 1.171, yes. So those are the 3 real zeros of our function. So the next question, part B, It says, what is the maximum number of non-real zeros that are possible for this function? Okay, so remember, non-real just means imaginary. Okay, so imaginary solutions or complex solutions that are not just real numbers. So remember we said that the degree of the polynomial tells us the total number of zeros that we should have, whether they're imaginary or real or not. Okay, so we should have 5 total. We had 3 real ones, which means we can have a maximum of 2 complex zeros or non-real zeros. So the answer would be that we can have 2 non-real zeros, a maximum of 2 non-real zeros, because the degree of the polynomial is 5. So there should be a total of 5 solutions. Are 5 total complex solutions, or zeros, and 3 of them are real. So that means there should be 2 non-real zeros. 5 minus 3 is 2. Please let me know if you have any questions. I hope you have a wonderful day.